Hello, welcome to Quadratic Problem Solving Day 2. We're going to really concentrate on solving quadratics using our calculator. And you can see the first problem is quadratic. When a ball is thrown upward at 80 feet per second from a height of 6 feet, the equation that models the path is, as we know, we've studied, that negative 16x squared, negative 16 is the constant of gravity, 80 is the original velocity, or the v naught, plus 6 is the initial height, which is h naught, where x represents time in seconds and y represents the height of the ball in feet. Okay, what we're doing now is, instead of solving using quadratic formula or factoring, we're using the calculator. So grab your calculator and let's type this into the y equals screen. If you have a bunch of stuff here, you can second plus 712 and reset it if you like. I'm going to type in negative 16x squared plus 80x plus 6. Now I want to get a good viewing window. So that's really what we're focused on here today, because when we graph this, if we can't see the solutions on the screen, then we need to make some adjustments. And hitting zoom fit isn't always the best, so I'm going to teach you how to adjust your viewing window. When you hit graph, you may not see the equation at all, or you may just see part of it that almost looks like two vertical lines. It's not. This parabola goes up really high and then back down like this. Well, I can see the solutions here, but I can't see the maximum, and I might need that as well. So let's adjust our viewing window. Now notice this normal scale, if you've got Zoom 6 or Zoom Standard on your screen, write that down. Zoom 6 is your normal viewing window, and you don't like it, then we can push window, and that'll give us this list right here. But before we do that, we want to make some guesses. That's really the best we can do. I can see that it goes through 0, 0, and probably 1, 2, 3, 4, a little over 5, maybe 0. So I need to at least include this where my x's are. So I've got a really good handle on what my x min. Maybe I'll go at negative 2, just so I can center this a little bit. And maybe I'll go a couple past on my x max. So I'll go from negative 2 to 7 right here. And the scale being 1, for each tick mark being 1, is a good scale. If I made each tick mark 5 or something, then it would be too crunched together. I like the distance apart right here. I could even go with 0.5 if I wanted it a little wider looking. Okay, and then my y minimum, well, you can see, well, you may not be able to see, but since this is an upside down parabola where it has a maximum, then I don't really need much underneath here. So where it's at negative 10 is probably fine. But I need a lot more height. I can only guess as to how high I want to make it. So right now that's 10. Let's take it up to 50 and see what it does. And then if I was going to do a scale of 50, I probably would want to have my, if I was going to do a max at 50, I would probably want to make my scale at least 2 and maybe even more. So let's hit the window button and give that a try. That's really what we're doing, is just estimating to start out with. We got the x min, x max. Now my y min, I'm going to say leave it at negative 10, but the max 50. And let's make our scale 2. When you graph that, see how tiny these are, and those are each 2. Love the x. We did a great job. Not happy with my y's. I'd say I need a whole lot more. Let's go up to 120. Let's give 120 a try. And if I'm going to go that high, I think I want my scale to be something more like 10 each. So like in this, like the minimum, but don't like that. So let's go and change that. X max, I'm going to change it to 120 and make my scale more like 10. And see if we're happy with that window. Ah, beautiful. Very nice, very nice. Okay, so now once you get a great viewing window and you're happy with that, use this space, I forgot I can't move that. Use this space here to kind of sketch it. I'm gonna do 1, 1, 2, 3, 4, 5. It doesn't have to be perfect, just kind of a, okay, that's terrible. Hopefully yours looks a little better if you're using pencil. Yeah, that's really bad. And then we did maximum up here of 120. This is 5, 0. Okay, just a little brief sketch to just tell me what you did. Then after you get a viewing window that you like, and keep in mind your viewing window could be a little bit different than mine, as long as we can see the maximum and the intercepts here, we're happy. Even if it's a little skinnier, a little wider, a little taller, a little more space, whatever, it's fine, as long as you can see those main parts that you need. Because the next questions are going to ask you to calculate with your calculator. Like for example, how high is the ball after 1 second? So how high is the ball after 1 second means t is 1. So if t is 1, let's go to our table. And remember, our x's were t and our y's were height. So if t is 1, y, or h, is 70. Are we in feet? Yeah, we're in feet. It's a good idea to put your units. And I got that from the table. Let's go back to the graph. The second question is, after how many seconds is the ball 80 feet high? So I want to say if the height is 80 feet, how can I find how many seconds have elapsed? And there may be two answers to that. One way you can do that is to type in 80 into the Y2 screen. And that would be like it equaled 80. And then graph it. And we're really looking for that point and that point, because there's two possible answers. So the ball would go up, 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 get to 80 feet, go even higher, and then come down and at some point be 80 feet again. The way to find that is to use second, oh, I forgot to write table on here. Use the table on number 1, Roman numeral 1. Roman numeral 2, we're going to do second, trace, number 5 for intersect. We're going to do that twice. If I just hit enter for first curve, enter for second curve, and enter for guess, it's going to pop to the closest value, the closest intersection that it is to the cursor. So I know one of them is going to be 3.77 seconds. So t is approximately 3.77 seconds. And then if I do it again and don't do anything different, then I'm just going to get the same answer again. So I need to do something different. I'm going to go second, trace, 5, and I'm going to make sure my cursor is closer to the other intercept there. Enter, enter, enter. That intersection point is 1.23. So t is approximately 3.77, or t and t is approximately 1.23 seconds. Two values there. Roman numeral 3, how long does it take the ball to reach its maximum height? I think we can all figure out that we're going to use second, trace, maximum. Remember for this, it asks you for a left bound, hit enter, then a right bound. So make sure that your left bound is on the left side of the maximum and your right bound is on the right side. It does not have to be a midpoint. It can be anywhere between them. And then do we want to make a guess? Not really. Hit enter and it will tell you your maximum is after 2.5 seconds it will reach the maximum height of 106. So how long? It takes 2.5 seconds to reach a maximum height. I'm going to make a note of this because you're going to have to know it for later. So this is the answer, but this is important for later and we don't want to have to do it twice. So we'll put in the height right there and the Hopefully you can see that. Okay, now the next question, it says for how many seconds is the ball in the air? That question is asking for how long does it take to get from here all the way back down to here. So for that, I think I would like to show you how to do a 0. Oh, let me write that down here too. For this one, you're going to do second trace 5 intersect. Oh, not 5, sorry. Second trace 4 for maximum. And then this one, how many seconds it's in the air, we're going to go second trace. All of these are in the same menu. And this time we want 2 for 0. So I'm going to click 2. Then when it says left bound, I want my cursor to be to the left of the 0. Now when it says right bound, I've got to move that cursor a long way to get it to the right side of the 0. Or actually, it kind of looks like it's underneath, but it is to the right. As long as that 0 is between your two lines, you're fine. And then when you hit enter, it gives you the 0. So for how many seconds is the ball in the air? It starts here at 0, it goes all the way up to 5.07. 5.07 seconds. Find a reasonable domain for the situation. Remember, the domain is the x's, so the domain can be anywhere between 0 and 5.07. It starts at 0 and goes to 5.07. And there is more down here, but for our problem, we are only using the first quadrant.